Okay, I'm going to do an furnace no heat call that we just got. And this is a gas forced air furnace, obviously. It's only a couple years old. And the homeowner woke up this morning and said that it was 60 degrees inside and the furnace was not coming on. So I came on the call, they had turned the thermostat off. I turned the thermostat back on and it immediately worked. So that indicates an intermittent type of situation, and the air handler was working and the gas fired up and it was blowing warm air. So it all seemed to be operating properly. So that usually, when you have an intermittent type situation, it's usually a maintenance issue, which is often related to the flame sensor almost certainly being dirty. There's another unit right behind us here in this attic, because this is a threeplex building, and there's one up in the same attic for two upstairs units in this apartment. So I'm just that's what you hear coming on that one. Okay, and the access was up through one of the apartments. Anyway, so I'm going to go ahead, and first thing I do is I look over everything. I turned off the power up top here on the switch, up on the light switch for the power for this. And I'm going to take off the covers, and I'm going to inspect everything. All right, so as I said, it's a new unit, new system. So the first thing I do is just look at everything, and I'll take pictures if I want to start taking anything apart, so I know that where wires were. I look for anything obvious that would be weird, like this is the inducer fan. Even though it's a low efficiency 80% gas furnace, it is a two-stage furnace because two-stage gas valve. So it's pretty basic, simple, not a high efficiency. But this inducer fan here is to induce a draft. I'm going to undo this other side here, which is where the blower and the control board would be. Okay, there we go. So here we've got the circuit board, and I just dusted off. It's just like brand new, you know. It's only a year or two old, so it's real clean. So nothing much to do in the cleaning part. So I'm basically going to just take a look at everything and then identify where the burners are, and the burners are of course right here. So I suspect that it's the flame sensor, and the flame sensor is right back in there. I don't know if you can see where I'm pointing, but that little thing there is the flame sensor, and then up here is the igniter. So when the furnace turns on, the gas, after it goes through a safety sequence and checks all the safety devices, it'll actually come over here and turn the gas valve on. It lets the gas go in, and the igniter has already come on, whether it's a clicker or a red hot surface igniter, we'll see in a second. And when that comes on, it glows or clicks, it sparks, and then the gas comes on and it lights. Once it lights, then the other burners consecutively, like instantly, go right down and light 1, 2, 3, 4, 5, right? This one has 1, 2, 3, 4, 5, so this is 100 BTUs. So anyway, it'll come on, it'll light and go all the way down here and light these. If for some reason this one doesn't light down here, it doesn't get all the way across, then it will not heat up that rectifying flame sensor rod. If it doesn't heat that up, then it shuts the gas off, because it indicates that it doesn't want the gas to run without all the burners burning. Safety again. So that's what my suspicion is that that flame sensor's dirty. So while it's still cool, before I crank it up and run a cycle on it, because it did run, it did come on. So the first thing I'm going to do is go ahead and just remove that flame sensor. And I'll do that by just pulling this wire off of it back here. 25 degrees outside, so I'm glad that it's an inside job here this morning. Okay, so I'm going to take off this flame sensor rod and pull it out, and then we'll look at it. And that's that. So, look, get up close to it here and see if we can get a good picture of this flame sensor. Yeah, I don't know if it'll focus that close, is it?
Not really.
So this is pretty dirty. So now it's here, and I'm going to use like a Scotch-Brite pad. It's just stainless steel. This isn't like a thermocouple or a thermopile that has a thin coating of bimetal or something on it that you could damage with sandpaper or anything rough. So I just use this to clean it off good with, like I said, like a Scotch-Brite pad here, you know. And I just clean it good because it's just stainless steel. And when flame is on that, when that sits in the flame, it creates a voltage, I think it's some kind of millivolt situation. The rectifying is a little complicated. But now it's all clean. Can you see it now? All clean and shiny stainless steel. So I'll put that back in now. And then I'm going to go ahead and do an ignition test, and we'll test a few other things while I'm at it. Just while I'm here, you know, because when you're here on a call, the expense of making the trip and coming out here has been already a sunk cost. So then it's important that you go ahead and do everything you can while you're here, because why not? It's good. Replace the wire. Okay, so now we're going to go ahead and I'm going to use a jumper like as if I turned the thermostat on downstairs. We'll see if it has a call for heat. I'm going to turn on the power to the furnace. And there's a safety switch right here on when you take the cover off, it won't run. So I have to hold that switch in. So I have a magnet situation that I use here when I'm doing these, so I can put that on there. Okay, you hear it click. So we're going to see if it's got a call for heat. The board is initializing over here. Okay. You hear the inducer fan came on to start the draft going. And it does that first. Okay, now the red igniter's coming on. You can see that back in there. You kind of see them in there. So you can see them as best we can. They're hard to see exactly. That's gas fire burning in there. And all the burners are on. And so it looks good. Nice blue flames. Now we're working operating properly. Once the firebox heats up for 20-30 seconds, whatever it takes for the burners to get the system hot, then the big blower fan motor comes on here, which is what circulates the air through the house. So that way it doesn't blow cold air. It waits till the furnace heats up, the burners heat up the heat exchanger for a little while, and then when it's a certain temperature, it kicks on the big blower fan, as you see in there, behind there. That's what sucks the air in through the air return and then blows it out. It blows it across the heat exchanger over this way, you know, across here, and then goes out through this into the ductwork of the house. And I'm going to let it run for a minute and make sure that there's not something else that needs to be done. The inducer fan is pulling 2.6 amps, which is good. And then it's going to go into low stage. Once everything lights up, we're going to watch this amperage drop back down. When it goes to low stage, it'll drop down to like 0.4. It's still at 2.9 on the inducer. The burners are burning. Okay, it just cut down to 0.8 now on the inducer motor. Okay, on the blower motor, we're pulling 4.6 amps with the door open here, so that's all good. We're good. All right, so we're done. So I think that I don't know what was causing the issue, but more than likely it was that dirty, corroded looking heat sensor, flame sensor I should say. And if the flame sensor's been cleaned now, we're just letting it cycle, watching it here, and there's really nothing else of concern. It seems like it's running fine. I don't need to jumper it because it's already calling for heat by the thermostat on its own. Okay, so now the flame's out. Once the flame goes out, per call's gone, then the blower motor keeps blowing so that it will cool down the heat exchanger, because the heat exchanger is hot. So the blower keeps blowing until the heat exchanger cools down, both for safety but also to use that energy and the heat in there that's already been generated and paid for. So it's getting that heat, still blowing it into the house as long as it's not cold already. And that's good for the heat exchanger too. And I'm wearing a carbon monoxide tester that is very sensitive, so there's no carbon monoxide being emitted here or in the unit, because I walked through the unit when it was running. It stayed in there quite a while, and if there was any carbon monoxide at all coming in, it would have registered. Okay, now the blower motor went off because the heat exchanger cooled down, and it's now on idle, standby, waiting for the next thermostat call. Okay, so I'm calling for heat again now. I'm going to turn off my lights because I want you to see in here when the heat exchanger, when the niter comes on. Okay, you can see it back in there now, probably orange, glowing orange. It's hard to do with this video, but now it's blowing orange in there, glowing orange. Now it's going to open the gas valve, and there's your blue flames flamed up, and the heat sensor is out. Heat rod, the flame sensing rod is obviously operating properly, or it would have already cut off the flame. So now the inducer just cut down to one stage. That's why it went a little bit quieter. It's sucking the exhaust from the flame all the way through that and through the heat exchanger. That's what this inducer fan blower motor is for, to create the draft, and it's sucking those gases through the jet burners in. And now when it heats up a little bit more, the blower motor is going to come on. There it is. Now the blower motor came on, and we've got a full ignition. Everything's running good. The burners are running, etc. All right, so that's it. Now we're going to go ahead and wrap it up because I think we're good to go. I'm going to take the call for heat off with my jumpers here. So now the thermostat's off. The flame went off. I'm going to leave the blower going for a minute before I take this off of my the safety switch on the door, because I want the blower motor to keep going so it doesn't overheat the heat exchanger. It says it fired up. So that'll go, and it'll cut off here in a second when it cools down. I'll just be putting my tools away here in the meantime, and we'll call that a wrap. I don't see anything else that would indicate a problem. I checked the thermostat already when I first got here to make sure that was functioning right. So it is. So this is the kind of stuff you need to do. This is a relatively new furnace, only a couple years old, and it needs to have the maintenance done on it, just like any kind of a part that has combustion or mechanical parts or whatever. You need to check it out, because the gas burns, there's dirty stuff in the gas, the natural gas is burning, and that will end up causing it to corrode on top of that sensor, on top of the flame sensor. And if the flame sensor gets coated with crap, then it can't sense. So now I can take off my override switch there for my manual, and we'll call it a wrap. And that is what is always over the board, so you can see a flash code of a light, an LED light on that board that'll flash codes if it has some kind of a code or error condition. And that's important, because on the inside of the same door, you'll have writing on there that has the like labels like this on the same one I just put on, and it'll have the flash code diagnostics. I see this one has it on both, so I guess you could interchange these doors. It wouldn't make any difference on this brand. So, of course, I want to make sure that I took off my jumper. Don't ever walk out leaving that on there. So it's all ready to go now. Everything is in good function. Everything's been checked. And since it's a new unit, I'm not doing a combustion analysis. It all looked good, and my CO's proved there's no CO. So we're pretty much wrapping up now. I'm going to pack up my tools and on to the next one.